This was the first VR ballistic missile in human history to be used in combat. Invented by Germany during World War II, 60 years ago it was already capable of reaching supersonic speeds of over Mach 5. It could strike targets 300 kilometers away. The VR ballistic missile is mainly divided into 4 sections: the warhead, equipment compartment, fuel compartment, and propulsion compartment. The warhead is installed at the very top. It has 3 fuses, a contact fuse, an inertial fuse, and another inertial fuse inside the warhead. Any of these fuses could trigger detonation. The warhead could carry nearly 1 ton of explosives, consisting of 60% TNT and 40% ammonium nitrate. Next is the equipment compartment, which contains the missile's guidance and control system. These are 2 electric gyroscopes. The horizontal gyroscope detects pitch deviation, while the vertical gyroscope detects yaw and roll deviation. This device here is an analog computer that controls the gyroscopes and other components. These are 2 batteries that power the equipment. This is the main power distribution board, which receives external power before launch. Next is the missile's fuel section, consisting of 2 aluminum magnesium alloy tanks. The upper tank holds fuel, the lower tank holds liquid oxygen. Both tanks are insulated with multiple layers of fiberglass and fixed in place by a metal frame. Next is the engine, which provides the missile's thrust. The engine is surrounded by 4 large stabilizing fins. The V-2 ballistic missile's engine was very powerful. It could launch a 1-ton warhead to a target 320 kilometers away and produce 25 tons of thrust for about 1 minute. The V-2 engine has a double-layer combustion chamber. Outside the chamber are fuel pipes that not only deliver fuel but also absorb heat from the combustion chamber to cool it down. In front of the chamber is a nozzle head, consisting of 18 small combustion cups that inject fuel and liquid oxygen into the chamber. The combustion cups are arranged concentrically, each with a liquid oxygen nozzle in the center and surrounded by 5 rows of fuel nozzles. The fuel and liquid oxygen reach these nozzles through the steam turbine pump, which draws them from the tanks and sends them into the combustion chamber through separate valves. On the turbine pump is a tank containing 175 kilograms of hydrogen peroxide mixed with water, and another tank of 22 kilograms containing 33% potassium permanganate and 66% water. These chemicals are fed into the steam generator, where they react to produce oxygen and steam, spinning the steam turbine pump to supply the engine with fuel. The V-2 missile was 14 m long, about 1.7 m in diameter, and weighed about 13 tons. When launching a V-2, heavy trucks transported it to the launch site. At the site, a launch pad made of welded steel, weighing 1.6 tons and equipped with adjustable support legs, was used to hold it upright even on uneven terrain. The base of the launch pad had a pyramid-shaped structure strong enough to withstand the engine's heat, and its shape dispersed exhaust gases horizontally during launch. When the missile was ready, clamps on the frame opened and the support frame retracted. Fuel was pumped into the tank, followed by liquid oxygen, then the steam generator chemicals. External power was connected to the main distribution board to power the missile. Once ready, the launch crew pressed the button to start the launch sequence. Hydrogen peroxide and potassium permanganate reacted in the steam generator to produce high-pressure steam, spinning the turbine pump at 3,800 rpm. The pump fed liquid oxygen into the combustion chamber at 17.58 pressure units and fuel at 23.8 pressure units. The oxygen and fuel mixed and ignited, reaching up to 2,500 degrees Celsius. Initially, the missile did not lift off. This ignition was to test the engine. If everything was normal, the turbine pump switch was turned on, increasing pump speed to 5,000 rpm and thrust to 25 tons. At that moment, the electrical cable disconnected and the missile launched. After a few seconds of vertical flight, the electric motor tilted the horizontal gyroscope, sending signals to the missile's fins to pitch sideways. After 25 seconds, it broke the sound barrier and reached Mach 5.7. The vertical gyroscope detected pitch, yaw, and roll deviations and sent signals to the analog computer to adjust the flight path. When the missile reached the speed needed for its range, the gyroscope's accelerometer signaled to cut off the engine. From that point, it flew like an artillery shell, relying only on its fins to maintain direction. The V-2 was not precision-guided, its targeting error ranged from 7 to 17 kilometers, so it was mainly used to strike densely populated cities. During World War II, German forces repeatedly used the V-2 to attack London, and because it could not be intercepted, it had a significant psychological impact on the British population.